folks, and welcome to another episode of Exploring Cryptocurrency. As of late, we are covering the basics before we get into more complex, or rather more specific topics and projects. And today we're going to be looking at what is, in my opinion, probably the most revolutionary project and concept that has happened in the cryptocurrency space, and that is Ethereum. A bit of background information. Ethereum has a sort of weird story. It was initially described in a white paper in late 2013 by a Russian programmer named Vitalik Buterin. He is a programmer who at the time was just a major Bitcoin enthusiast. This is a young 19-year-old kid whose father was a computer scientist, introduced him to Bitcoin. Vitalik ends up getting obsessed with this technology, and he co-founds a publication called Bitcoin Magazine, and he ends up writing for this magazine. And at this time, prior to 2013, Bitcoin had only been around since 2009. The only people really talking about it, at least in detail and in terms of solution-driven discourse, are developers and other computer scientists and programmers all over the world. Vitalik gets involved in this dialogue, right? And he had been advocating for this idea that Bitcoin needed its own scripting language for developing applications. Buterin wanted to be able to build applications on the blockchain. And as it happens, this idea wasn't really received that well. So he proposed development of an entirely new platform, the platform that we know today as Ethereum. So, what is Ethereum? The question of the day, right? At its simplest, Ethereum is an open software platform based on blockchain technology that enables developers to build and deploy decentralized applications. And I promise you will understand what those are by the end of this episode. Decentralized applications, or dApps. Is Ethereum similar to Bitcoin? That's another really good question. And the answer is, well, sort of, but not really. Like Bitcoin, Ethereum is a distributed public blockchain network. Although there are some significant technical differences between the two, the most important distinction to note is that Bitcoin and Ethereum differ substantially in purpose and capability. Bitcoin offers one particular application of blockchain technology, a peer-to-peer electronic cash system that enables online Bitcoin payments. While the Bitcoin blockchain is used to track ownership of the digital currency, Bitcoins, the Ethereum blockchain instead focuses on running the programming code of any given decentralized application. In the Ethereum blockchain, instead of mining for Bitcoin, miners work to earn what is called Ether, a type of cryptocurrency token that fuels the Ethereum network. Beyond a tradable cryptocurrency, Ether is also used by application developers to pay for transaction fees and services on the Ethereum network. So that kind of sounds familiar. We talked about Bitcoin in our last episode, so this is sort of a similar idea. They're using a proof of work consensus algorithm. Miners are being rewarded in their native token Ether, which, by the way, I should note, a lot of people, pretty much everybody, calls the Ether token Ethereum. So when you hear that, don't get confused. People just call it Ethereum. I don't know why, that's just the way it is. However, there's also a second token in Ethereum. The second type of token is used to pay miner fees for including transactions in their block, and this is called a gas. And every smart contract execution requires a certain amount of gas to be sent along with it to entice miners to put it in the blockchain. It's smart contract, another key term that we're going to be learning all about today. First, I thought it'd be a good idea to see what the actual Ethereum Foundation describes their own project like. How do they describe this? Well, quote, Ethereum is a decentralized platform that runs smart contracts, which are applications that run exactly as programmed without any possibility of downtime, censorship, fraud, or third-party interference. These apps run on custom-built blockchain, an enormously powerful shared global infrastructure that can move value around and represent the ownership of property. This enables developers to create markets, store registries of debts or promises, move funds in accordance with instructions given long in the past, like a will or a futures contract, and many other things that have not yet been invented, all without a middleman or counterparty risk. The project was bootstrapped via an Ether pre-sale in August 2014 by fans all around the world. It is developed by the Ethereum Foundation, a Swiss nonprofit, with contributions from great minds across the globe. So that's how the actual Ethereum Foundation describes their project on their website. And honestly, that's a pretty darn good explanation. It's very straightforward, it's true, it's not overcomplicated, most importantly. And I say that because if you're familiar with the cryptocurrency space and you've read about projects, man, there are really some projects out there where you read their front page at their foundation or whatever organization is behind it, and you just sit there scratching your head like, what the hell? Like, what did I just read? That's why we have Exploring Cryptocurrency podcast. So, yeah, there's a lot of jargon in this space, and I really try to get around that, which is why, by the way, and speaking of which, we are going to understand dApps and smart contracts because this is essential stuff to understanding Ethereum because this is really the core of what Ethereum is. With that said, now we're going to take a look at what a smart contract is if we're to truly understand Ethereum. A smart contract is just a phrase that is used to describe a computer code that can facilitate the exchange of money, content, property, shares, or anything of value. When running on the blockchain, a smart contract becomes like a self-operating computer program that automatically executes when specific conditions are met. Because smart contracts run on the blockchain, they run exactly as programmed, without any possibility, again, of censorship, downtime, fraud, or third-party interference. Smart contracts help you exchange money, property, shares, or anything of value in a transparent, conflict-free way while avoiding the services of a middleman. The best way to describe smart contracts is to compare the technology to a vending machine. And this is a pretty popular analogy in the cryptocurrency space. It comes up quite a bit, and I think it's a pretty good one. Ordinarily, you would go to a lawyer or a notary, you'd pay them, and you'd wait while you get the document. But with smart contracts, you simply drop a cryptocurrency token into the vending machine, i.e. the ledger, and your escrow, driver's license, or whatever drops into your account. More so, smart contracts not only define the rules and penalties around an agreement in the same way that a traditional contract does, but they automatically enforce those obligations, and that's what makes them really cool. So the next interesting thing in Ethereum that Ethereum implements is dApps. Some people also pronounce this dApps, kind of like emails, but all you need to know is dApps stands for Decentralized Applications. It's really difficult to summarize dApps in a 1 to 2 line definition, as an application needs to have a specific set of characteristics in order to qualify as a dApp. A dApp is, in short, an application implemented on a blockchain, but we can define it much, much farther than that. First, let's take a look at what constitutes as a dApp, those aforementioned specific characteristics that it must have, right? There are 4 of them. And keep in mind, if an app does not meet all of these criteria, then it's not a dApp. So criteria 1 is open source. The application must be open source, meaning its source code must be available to everyone. The second point, decentralization. It needs to use a blockchain-like cryptographic technology. 3, incentive. The application needs to have some sort of incentive system, like a crypto token or digital asset that fuels itself. And 4, algorithms and protocols, generating tokens and having an inbuilt consensus mechanism. What we're really getting at here is dApps are basically or can be cryptocurrencies in and of themselves, and many of them are. We'll take a look at a couple of examples at the end of this explanation of what decentralized applications are. So dApps function by implementing these 4 criterion. This means that a dApp is an open source software platform implemented on decentralized blockchains. dApps are fueled using tokens, which are generated by using any number of unique protocols and algorithms. Being an open source application makes it truly decentralized as anybody can see and contribute to the code. And it also hastens the possibility for scalability of product development in terms of both quality and quantity. I mean, just look at the Ethereum project itself. Like, you've got hundreds or thousands of developers and very talented computer scientists all over the world communally working as a community on a mutual goal, a mutual project, an idea. Things are going to get done a little bit quicker. And decentralizing the app by using a blockchain is pretty much the final step with creating or taking an application and making it a decentralized application. The Ethereum white paper splits dApps into three types: applications that manage money, applications where money is involved but also requires another piece, and applications in the other category, including things like voting and governance systems. So, in the first type of application, a user may need to exchange Ether as a way to settle a contract with another user, using the network's distributed computer nodes as a way to facilitate the distribution of this data. The second type of app mixes money with information from outside the blockchain. For example, a crop insurance application that's dependent on an outside weather feed. So, say a farmer buys a derivative that automatically pays out if there's a drought that impacts his work. To execute, there would be a smart contract that relies on so called oracles, right? And these oracles relay up to date information about the outside world. This is pretty cool, right? Somebody could be relying on outside information to implement a contract on the Ethereum network. So now comes the third type of decentralized application, and this is where stuff gets really, really interesting. If Bitcoin can do away with financial authorities, it begets a question of if it's possible or not to do the same thing to actual companies, corporations, and other types of organizations. This is a third type of dApp. It's called Decentralized Autonomous Organization, or DAO. And this is one particularly ambitious breed of dApp. The goal here is to form a leaderless company, program rules at the beginning about how members can vote and how to release company funds, etc., and then just let it go on the network. And I'm going to have to come back to this one at the end because it deserves a little bit more discussion, but speculative discussion, because when we talk about DAOs, we're really talking about the future of cryptocurrency technology. We're talking about fully autonomous organizations that are run by code, by software, by even artificial intelligence implementations. We're also talking about the idea of removing personhood from finance, which is so revolutionary because forever in all of the history of money, we have always associated the operability of personal finance with personhood. You either need to be a person or a group of persons in order to have and manage money. But when we talk about DAOs, we're talking about machines using money autonomously, whether or not that was pre-programmed by us notwithstanding. So here are some, as promised, examples of tokenized dApps. Two that I think are kind of cool. We have Golem. So the Golem project basically aimed to create a first global market for idle computer power. And basically what this project was doing was they released this version called Brass Golem, and they were tested on its ability to tackle CGI rendering, which was the first use case, just as a sort of beta test, right? And this turned out to be pretty successful, and CGI artists were able to rent computing resources from other users around the world to render an image faster. This means they could rent idle machines that would accept tasks from other users and get paid for it. This is frictionless sharing and pooling of resources. Imagine that. Say you have an idle machine, you've got computing power, you can rent that to some guy on the other side of the world who's working on digital rendering and eventually even more wide arrays of use cases. The other project I'm going to touch on real quick is Augur. Augur would fall under the second type of dApp in that it is basically a prediction market concept. What it does is it creates a forecasting tool, and this is used for potential trading gains. And Augur is incorporating, therefore, outside information from the blockchain into the blockchain. And both Golem and Augur are tokenized assets. You can go on a cryptocurrency exchange right now. You can buy them, you can invest in them, you can trade these, which is why in previous episodes I've said that when you buy a cryptocurrency, you're really buying a stake in a technology. There is intrinsic value to this stuff because these are like shares in a company. I mean, you're holding stake in the value of these technologies, of these decentralized applications, and all their use cases. I mean, obviously, with Gollum, we're seeing this idea of creating a global market for renting idle machines and computer resources, which is pretty cool. And it's not very far fetched when you think about ideas like Uber and eBay or Airbnb. So, in fact, there are also a lot of cryptocurrency implementations of those services as well. Surprise, surprise. So, what makes Ethereum unique? While all blockchains have the ability to process code, most are severely limited. Ethereum is very different. Rather than having a set of limited operations, Ethereum allows developers to create whatever operations they want. This means that developers all over the world can build thousands of different applications that go way beyond anything that we've ever seen before. And before the creation of Ethereum, blockchain applications were designed just to do a very simple, limited set of operations. Bitcoin and other cryptocurrencies, for example, were developed exclusively to operate as peer to peer digital currencies. Developers faced a really big problem here. They could either expand the set of functions offered by Bitcoin and other types of applications, which is complicated and time consuming, or they could develop a new blockchain application and entirely new platform as well. Recognizing this predicament, Vitalik Buterin developed Ethereum. And Ethereum's core innovation is this thing called the Ethereum Virtual Machine, EVM. And the EVM is a Turing complete software that runs on the Ethereum network. And by the way, when people say that Ethereum is Turing complete, I know I've read this so many times, I've heard this so many times, and people just say, oh, yeah, it's Turing complete. Like everybody knows what Turing complete is, right? I'm going to tell you what that means. Um, Turing complete basically means that it features a fully functioning programming language that is available on the Ethereum blockchain. So Ethereum has its own coding language called Solidity, and it is a specific smart contract language in that it is specific to Ethereum. The Ethereum virtual machine enables anybody to run any program, regardless of the programming language, given enough time and memory. You can also write these smart contracts again using the aforementioned Solidity coding language, and the Ethereum virtual machine makes the process of creating blockchain applications much easier and efficient than ever. Instead of having to build an entirely original blockchain for every new application, Ethereum enables the development of potentially thousands of different applications all on one platform. And that brings us to the last aspect of Ethereum to note, and that is the ERC20 standard. If you get really into Ethereum, which I wouldn't be surprised because Ethereum's a really cool project, you're going to hear the term ERC20, ERC20 token, ERC20 standard. So let's go over what the ERC20 standard is. ERC20 is a technical standard that is used for smart contracts on the Ethereum blockchain for implementing tokens. ERC stands for Ethereum Request for Comment, and the 20 is just the number that was assigned to this request. In short, the ERC20 standard defines a common list of rules for building new cryptocurrencies on Ethereum. This list of rules is a series of specifications that all Ethereum's tokens must follow, ensuring that the token allows developers to accurately predict how new tokens will function within the larger Ethereum ecosystem. The impact that ERC20 therefore has on developers is massive, as projects don't need to be redone every single time a new token is released. Rather, they are designed to be compatible with new tokens, provided those tokens also adhere to the ERC20 standard rules. Most altcoins or other cryptocurrencies other than Bitcoin that we use are actually ERC20 tokens. And to give an example of the breadth of this, just as of November 2018, there were a total of 142,733 ERC20 compatible tokens on the Ethereum mainnet. So that's pretty damn sizable, and it's only grown since then. So there you have it, guys. Ethereum. This is clearly a really powerful, incredible project and suite of revolutionary technologies. In future episodes, we'll be looking at the ERC20 standard in depth and learning what the rules of the standard are. We'll also have to take a look at possible use cases, especially those in automation and artificial intelligence. I remember I mentioned that third type of decentralized applications. I think it deserves its own episode because these applications are seriously, they're just mind-boggling. It's this specific aspect of cryptocurrency, in fact, that just got me really obsessed with this technology. As always, thank you folks for listening. This has been another learning excursion on exploring cryptocurrency. And be sure to subscribe, rate, and share our podcast, particularly on iTunes, with others so you can introduce more people to this awesome technology. And with that, I bid everyone a wonderful day. Until next time.